Okay, topic that we covered last Thursday and Friday was simplifying expressions. So something that looked like this. Okay, the basic concept was you had to rearrange the problem. There's two types of expressions. This was the first type. Doesn't matter if they have any extra letters. I know we talked about this last week. And extra numbers, doesn't matter. You have to rearrange. That's one of the types. So if you were to rearrange, I don't care the order you put it. You just have to group things together. And again, I don't care which order you put them. Maybe you want to put the M up front. Maybe you want to put the 4x and 2x in the back. But you're grouping items by their like terms. That step is called commutative. That was one of the types of expressions that you have on that worksheet that you had to simplify. Expressions like this take 3 steps. That's a normal expression. There's rarities where they could take an extra step or an extra 2, depending on what the look is. But this is the first type that we talked about. You have to rearrange. That's commutative. Commute means to group and move. So we rearranged. Then the next step is everyone always wants to write 6x and 15, but you can't. You have to factor off the x because the numbers have to see each other before you can add them together. The x's are separated, so you have to pull the x off the label so you can see what numbers you're actually going to add. Back here, this 12 and 13 are already pushed next to each other, and there's no m's. If there's any other m's, you do the same thing. You factor out the m. That's called factoring or reverse distribution. That's what my other geometry classes call it, reverse distribution. It's not normal distribution. You're going kind of backwards. You're pulling things out of a parenthesis, not putting it in. But that's factoring. That's the typical term. That's what most people write. And then you want to simplify them down. So you want to do your last substitution step, your closure step. Right, 6x, the 15, the 7m. You can push them closer together. I like to separate them so you can see it. That's the final answer. That's as far as you can go on this problem. And then again, that was substitution. Substitution is always closure. It's usually the last step you always have. You always have to do that final math in the problem. The only way that this problem would be different, and not just the answer, I'm talking about more steps or whatever you have. Maybe they forgot the number in front of the x. So if they don't have a number sitting here, you can always introduce a number 1. You can always put a 1 in front of any variable. The reason why it's called multiplicative identity, you multiply by 1. That's one of our properties in your property sheet. So if you want to introduce the number 1 in front of a variable, you could put that right in the first step, right where they have it printed. Put a 1 and write multiplicative identity, and then just do the normal work that we just did here. That'd be the only difference, because at some point you have to add, 1, 2, 8. Now, the other type of problem that we had on that worksheet was if you had to distribute something. Normal distribution, not this weird stuff where you're taking things out of the parentheses. Something like this. Let's say this was a 3, you have a 6 minus 2m, and you have, I'll just stop there. I could put more, but let's say this is my problem. That's the first start of it. I think you have 1 or 2 of these where you have to distribute. You have to first just hand out this 3 to both items. That's distribution. Notice I'm not going to write down the answer. You're just going to hand the 3 to each item. That's distribution. That's what you have to do on some of your problems. I think number 2 and number 4 on that worksheet that you have to do that first. You have to distribute. You have to hand out the item into the parentheses. There was one of the problems. I don't know if it was number 2. You have to do it on there was 2 different parentheses going on. You do it at the same time, just to distribute over them, and just write distribution. It's your one property you did over the whole problem. Then you should always switch the parenthesis bars so the numbers can see each other. That's a step that some people tend to forget. You have to switch the parentheses, which is called associative. Associative should always follow normal distribution. You always have to change the parentheses so the numbers can see each other. Then the last step is sub again, where you just go, okay, this is 18, this is 6, and that's your final answer. Substitution is closure. I think there was one problem in particular I saw on your worksheet where you had to go further. Maybe there was another number back here, or numbers, and you had to add them. So then, once you get through these normal steps where you distribute, maybe you have to do this stuff next. where you have to commute, you have to move things around, you have to factor if there's variables you have to add together, and then substitute. Sometimes you don't even have to do that. Sometimes you don't have to rearrange. You can just go right into, factoring and substitute, or maybe it's just adding numbers together, so it's just substitution. You only factor if it's variables. You're going to pull that letter off. That's how you add letters correctly. Variables, I should say. Questions with what you have to do in the worksheet. You have to show the work, like this. You have to write the property names down. It's kind of like what we did in the equation worksheet that was due last Friday. Okay, that assignment that you're looking at, that worksheet, is due tomorrow. So keep that in mind. So you have a little bit of time today. My goal today, as you can tell on the board, is just to introduce a new topic. We're still in algebra. We're still doing some algebra facts. But we're going to be looking at this stuff, but in a different light, kind of like the newer stuff. So this week, we're going to look at 3 small assignments. 3 small ones. Like, I consider these worksheets, the ones that you're doing right now, these are big. That's a big worksheet. You have a lot of properties, lots of steps. The stuff we're going to do this week, though, is really easy. Like, this is an easy week of algebra. Just to review facts, the reason why is that when you get into the heavy geometry stuff, it's nice to be able to fall back to some basic algebra that you can actually use. You're not lost. You know exactly what to do, what's expected of you. So I do this every year with every geometry class. We always cover the same kind of sections. Well, there's one section in particular you have to graph a lot. So we need to look at graphing. But before we get to the new stuff today, is there any questions on the old stuff we did last Thursday, Friday? Perfect. Okay. Parent-teacher conferences this week. I think it's tomorrow and Thursday. We do not have classes this Wednesday this week, so keep that in mind. We have classes on Wednesday. Pretty much this week is, do some notes, get small assignments. So we'll look at our first small assignment tomorrow. And then Thursday, Friday, we'll look at really tiny assignments as well. We just do little pieces where you do them like almost in class together, just so you can get some easy points. You know what to do, you know how to do it. Questions though with the kind of the outline this week. Okay, should be pretty easy. It's a nice little week in geometry. It'll be a lot easier than what we did last week. Last week that's tough. This is tough stuff you're doing right now. Okay, so here's what we're doing today. New stuff. We have to graph on a coordinate plane. We have to put coordinates down. You have to draw them. And so I want to review just a couple facts. We've done this stuff before, I think in the beginning of the year, but we got to refresh our memory on how to do this. I think we did it when we were doing distance and when we were doing midpoint and stuff. We kind of reviewed this stuff. This is the Cartesian coordinate plane. Cartesian coordinate plane. It's a 14th, 15th century math concept. It was made by a French mathematician, René Descartes. He was a poet, philosopher kind of thing. He's got some good quotes if you ever look up René Descartes. Created this concept of how to graph. He also created a major concept of pre-calculus. He did some serious math. And so this is a concept we still use just for ease of use of graphing. So the stuff I want to review today, I want to review some vocab terms with this coordinate plane. So some vocabulary terms. Stuff that we've talked about before, just kind of refresh your memory. It's been, I don't know, about almost a whole unit since we've seen this. And then obviously talk about graphing, how to actually do stuff on it. And we're just going to keep it real light and real basic today. Like, I want to be done here in about 10 minutes or so, and then let you have time where if you need to work on that worksheet, you can work on that, because I did promise you to have some time today. All right, so let's jump right in. Okay, so we have the coordinate plane. You can call it an XY graph, just a coordinate graph, a plane, whatever you want to call it. Correct term is Cartesian coordinate plane. It's got an x-axis, a y-axis. You can see those. So that's the bold lines here. You can graph on them by just knowing 2 numbers every single time. The 2 numbers are always in alphabetical order. It's always alphabetical. That's what they're called ordered pair. That's one of our vocab words. So ordered pair, or a coordinate. It gets you anywhere on this graph. You just have to have 2 numbers. So you can have, now on the traditional graph, like the graphs like that, my graphs go up to 12. So that's pretty traditional if you look them up online. It's just kind of a standard. It's up to 12. If it were to change, let's say on like on a test, or to print a really goofy graph for you, something like that, and you had to plot on it, and it wasn't by 12s, I'd probably clearly warn you of that, just so you're not, because when I start graphing, I really use the fact that it goes up to 12s to graph quickly. So like for instance, if I had to graph 7, 3, I don't count over 7, because I know it's over 7, not 3, but the problem is I can do it faster. Because what does it go out to? If I start here, how many numbers go that way? 12. So I can be 5 from the end. 1, 2, 3, 4, 5. So the idea is that this is 11, 10, 9, 8, 7. That's how quickly I can draw. So this is over 7, up 3. There's where the dot is actually found. That's how I graph it like quickly, because I know it goes out to 12. So I just go 5 from the end and up 3. And you typically label them with capital letters. That's how you label points. That's just the concept. The first number is right and left. The second number is up and down. So the things that you'll notice from years of just doing this is that this type of thing usually messes with people. When you throw zeros in there, for some reason it just causes issues. Just remember the first number is right and left. So if you're walking into the hotel, you're sticking in the zero elevator, so that's the one right in the middle of the lobby. These are positive elevators, negative elevators, and you're going down to the -6th floor. Well, that's kind of in the middle. This looks like the middle for the bottom. So 1, 2, 3, 4, 5, 6, yeah. And we'll call that point B. That's how you get anywhere on this graph. Questions with graphing at all? Okay, now vocab terms. Obviously, we're talking about order pairs, talk about points, locations in space labeled with capital letter at this point. Quadrants. There's 4. Let's refresh our memories. Where's quadrant 1? Top right. Okay, and this quadrant 1 up here, it's the entire box. We label it with capital or Roman numeral. Where's 2? Top left. They go counterclockwise. Now, the reason why we talked about this in class, in the last unit, not as, it had been 2 units ago we talked about it. When you draw angles, that's why they're labeled counterclockwise. One starts over there, because when you draw angles in standard position, they always go horizontal to you, and then you're supposed to open up counterclockwise. Imagine this is ground level and you're raising the cannon up in the air. That's why this would be the first quadrant. That's the first one you'd hit when you draw your angle. Then as you keep opening the cannon, you'd eventually hit over here. Well, that's why this is the second quadrant. Then eventually you keep going behind you and down. That's the third quadrant, and then the fourth quadrant, and eventually be over here. Okay. Now that's positive angles. You're always going counterclockwise because you're going from ground level up. If you do negative angles, that's something we never discussed. Negative angles, instead of going counterclockwise, they look down. Maybe you're on the top of the hill. So here's your hill. You're looking down like that. That's a negative angle because you have your horizon in front of you and then you're looking down. That's a negative angle. Maybe that's negative 10 degrees. Why you'd ever have to do that? If you're on an airplane, you have to go land, you have to go through a negative angle, angle of depression. Angle of depression means look down. That's the idea. So those are quadrant systems. You can get anywhere on them by just knowing 2 numbers. Doesn't matter. Can somebody give me a coordinate to get in quadrant 3? -7, -8. I like that. Okay, let's call it C. So -7 over, and then -8. 8 would be there. So again, it's 5 from the back. That's 12, 11, 10, 9, 8, 7, and then you're going down. 8 is 4 from the bottom. So that's the letter C. B is not in the quadrant. B is a quadrantal, it's in between. C is definitely in quadrant 3 though. Okay, questions with the coordinates. Okay, now I'm not joking, like tomorrow, one of our in-class little activities we're gonna do, like to start tomorrow, is we're gonna look at graphing, dots, coordinates. I'll give you coordinates and you're gonna have to go draw them. And we'll play a little game in class tomorrow, so I think you'll enjoy it. Okay, questions. Okay, we'll look at that stuff tomorrow. It's in about 10 minutes, I'm on about 6 or 7. You have the rest of the time today, about 20 minutes or so. I want you to have time to work on this worksheet, part 2. It's due tomorrow. Now, if you already have it turned in, I'll let you know here in a second. I'll go take a look to see if you have it turned in or not. Homework from Friday, if you have not turned in worksheet number 1, part 1, that's the equation part of it. Make sure that gets turned in. When you do equations, it takes you 4 steps or more. Expressions, this worksheet that's due tomorrow takes 3 steps or more, depending on what your problem is. Okay, that's it for today. Pretty easy.